On organic amendments. My name is Matthias Becker. I'm from the University of Bonn, and I have the privilege of chairing this session on organic amendments. We will have 5 presentations addressing issues of organic amendments necessarily. We're looking at mulch, looking at composts, looking at farmyard manure, looking at biochar and at ashes. And we have presentations that deal with the effects of those organic amendments on yield and growth, on soil attributes, on product quality, and also in one case on weeds and weed suppression. And we have contributions from Sub-Saharan Africa, that will be a meta-analysis, followed by presentations from Tanzania, Bolivia, Cuba, and Kenya. I think without much further delay, we are going to start with Jill Graham. Jill is talking about combining organic and mineral fertilizers in climate-smart soil fertility management. Jill has done his work at IITA together with colleagues from Leuven. And I think, Jill, you just share your screen and we start off with your presentation. We all look forward to it. Please give it a try.
Unmute, share screen. All right, you can hear me? Okay, thank you, Matthias, for the introduction and for the opportunity for me to present our work. Good morning, everyone. Thank you for being here and for your interest in my presentation, which will be about the paper we recently submitted, where we conducted a meta-analysis about whether the combined application of organic and mineral fertilizers can be regarded as a climate-smart agriculture integrated soil fertility management practice in sub-Saharan Africa. So as Matthias said, this work was in collaboration with the IITA and the University of Leuven. So our work is based on the fact that sub-Saharan Africa relies heavily on staple food crop production for its food security, yet it is struggling with 2 major challenges. The first one is low yields due to chronic land degradation. And on top of that, we have climate change that is exacerbating these low yields. So in order to address these 2 major challenges, there would be a climate-smart agriculture that is required to integrate climate change adaptation and, if possible, mitigation measures into the food security strategies. So one sustainable intensification framework that has been promoted for more than 30 years now in sub-Saharan Africa is the integrated soil fertility management framework, of which we have a major component, the combined application of organic and mineral resources. So in this work, the objectives were to assess whether this combined application could be called climate smart in terms of increasing yield productivity and agronomic efficiency, in terms of reducing the yield variability and therefore increasing the food production resilience, and in terms of increasing soil organic carbon and thereby offsetting greenhouse gas emissions. We also wanted to know whether these effects were influenced by organic matter quality and the nitrogen input rates. We chose to focus on maize and mineral and nitrogen fertilizer because they're 2 very important elements in sub-Saharan agriculture. And so a lot of research had been done on them, and so a lot of data is available for meta-analysis. Our meta-analysis was conducted by the use of linear mixed effect modeling. We don't have enough time to go into details, but basically those linear mixed effect models allow for the assessment of the input treatments effects on yield and soil organic carbon, while taking into account random variation, which is caused by inherent differences between studies and site characteristics, such as soil type, climate, etc. The data used for the modeling was selected from a series of short and long-term maize nutrient trials across sub-Saharan Africa that were subjected to a number of selection criteria. And the main one is that they needed to address 4 treatments, which are the control, the organic resource only, the mineral resource only, and then the combined application. One major data preparation we did was to classify the organic quality into different quality classes. So class 1 and 2 were considered high quality because they're nitrogen rich. And then class 3 and 4 were considered low quality since they're nitrogen poor. An extra class was created for manure since it's a very variable resource. So going to the results of the first analysis, where we modeled the yield, we came up with yield response curves you see on the left side and the agronomic efficiency response curves on the right side. In blue, we have the mineral fertilizer only treatments. In beige, we have the organic treatments only. And then in orange, we have the combined treatment in different proportions. So I will keep it to three important observations. The first one is that with increasing total nitrogen input, we see that the yields are increasing for the yield response curves. And we see that the agronomic efficiency goes down with increasing inputs of nitrogen. The second observation is that the organic quality matters. So you see that the response curves of the classes 1, 2, and manure are quite similar as opposed to the low quality class 3. So for yield responses and for agronomic efficiency responses. But more importantly, we see that the yields and economic efficiency of the combined application is always outperforming the organic ones and will also outperform the mineral treatments at a certain nitrogen input range. So this means that for the high quality classes, we observe a positive interaction between organic and mineral resources, while this was not the case for the low organic quality classes. So it seems that at low nitrogen input rates, the pure mineral nitrogen was being efficiently used and converted into higher yields, but that this efficiency goes down with more nitrogen being applied. But this was not the case for organic treatments. So if you would combine the two, we achieve higher yields and a more stable economic efficiency across the nitrogen input range. Going on to the results of the second analysis, where we analyzed the yield variability over time, we used the same yield model outputs from before, where we were able to extract the predicted yield variance of the different treatments over time. So we used those variances to calculate variance responses compared to the control and made those relative to the predicted yield. So the idea is that these relative variance responses give us an idea about the differences in yield variability between the treatments and subtreatments. You see very clearly that there is an organic matter quality effect here, where there is a low variability for the high quality organic resources and a high variability for the low quality resources. You see also that the combined application doesn't really differ that much from the organic ones, meaning that the variability is mainly determined by the organic resources. Going on to a third and last results of the analysis, where we modeled this change in soil organic carbon across cumulative total nitrogen input. Why cumulative? Because we wanted to integrate the aspect of time, since soil organic carbon is a very dynamic process and the measurements are a snapshot of that dynamic process. So it's very important to keep track of the aspect of time, and including time as such in the model was unfortunately not possible. So that's why the cumulative total nitrogen input. We see here as a main observation that first of all, the soil organic carbon goes up with increasing nitrogen inputs. But we also see that this was not the case for the mineral resource. In fact, the mineral resource was not significant according to the model. Otherwise, you can see that the organic classes also matter, but this will be more visible into the next analysis we did, where we modeled the change in soil organic carbon, not to the cumulative nitrogen input, but to the cumulative carbon input. So it's basically the same soil organic carbon changes, but from a different perspective. Here we see very clearly that the high quality organic resources are the ones that actually cause a positive effect on soil organic carbon, whereas the low quality organic resources have a very small effect or none. In fact, the lowest quality class 4 was not even significant. We also see here that the mineral nitrogen effect, the mineral nitrogen treatment had no effect. And that also means that the combined application was also not different from the organic application. This also means that, in contrary to what is often claimed, is that mineral nitrogen is not degrading or facilitating the degradation of soil organic carbon, but neither is it increasing the soil organic carbon via, for instance, increased root biomass. So in conclusion, we could say that in relative terms, if you compare the combined application versus the separate applications, the combined application only has a significant positive effect on maize grain yield, productivity, and agronomic efficiency at higher rates and for high quality resources. But for yield variability and soil organic carbon, we cannot say the combined application performed better or worse than the organic only treatments. So if you were to apply the combined application into practice, this also means that this combined application with high quality nitrogen would combine the best of both worlds, meaning we would achieve a high productivity and economic efficiency, which is more stable across nitrogen input rate. And that would be because of the mineral nitrogen parts in the combination. But we would also achieve a low yield variability and the most positive effect on soil organic carbon, which would be due to the organic part of the combination. So what is a combination practice then? Could it be called climate smart? Well, we think it is, and we would therefore recommend it as such. Thank you for your attention. I'm open for questions.
Thank you, Jill, for this very interesting analysis. And the floor is now open for questions. I'm looking at the Q&A. It's too early, probably. There's nothing yet. Let me just start it off a little bit. This higher efficiency, or I think this lower variability in yield, is a very relevant aspect that's often underrated a little bit. And I think for farmers, high variability means a high risk of, the risk in the outcome of the investment. So I think it's a very important aspect to consider. Could you please elaborate? Do you find big differences between agroecological zones in terms of this differentiation between organic and mineral combinations?
We didn't look into those zones as a main research question. We took them into consideration to reduce the variance, so the variability. So we allowed the model to take into account there would be different agroecological zones, but we didn't look into them specifically. So I could not answer that question.
Mm-hmm. And when we come to looking at the quality of your products, you defined high quality, low quality. What beyond the nitrogen or the CN ratio is defining quality in your study?
Yeah, so in our study, I did not have enough time to really go into it, but we looked at the lignin content and the nitrogen content. So the classes, the high quality, which we call high quality, is both high in nitrogen, but the class 2 has more lignin than the class 1. So it's considered a less quality. And then for the low quality ones, we have poor nitrogen contents, but there again, the lowest class, so the class 4, has more lignin than class 3.
Mm-hmm. Okay. May I just follow up with one more question? Can you give an example of a typical high or typical low quality amendment?
Yeah, so the high quality is typically Tithonia diversifolia. For instance, it's like those high leguminous, the green leafy organic matter. And then the low ones would be like class 3 would be maize stubble, so maize residues, the brown part. And class 4 is the absolute lowest, which is sawdust. So it's pure, almost pure carbon. Yeah, but that's okay. There was a little data on it also because it's pretty specific. Class 2 would be, for instance, Calliandra. So it would also be the leguminous trees, but more the woody ones.
Okay, but Tithonia is not a leguminous, it's the Asteraceae.
Yes, true. You're right.
Okay.
I'm thinking about the other ones, yeah.
I'm looking at the Q&A. Don't lead higher N fertilizer inputs to higher nitrous oxide emissions, ? This is a question from Lawrence Bachman.
Yes, it's a good question. We didn't look into that because we only have so much we can look into, but it's definitely a good question, especially relevant for higher inputs. So the more nitrogen you will apply, the more you will have this effect. But I think that's why the combination would work well, because you can, the nitrous oxides emissions would be typically with mineral nitrogen inputs. So if you would mix those with an organic inputs, you would have a much more balanced way of application. And to my opinion, that would also mitigate a bit those emissions. But of course, we did not look into that in this analysis.
Mm-hmm. In the Q&A, there is just a comment by Raul Lopez from Cuba, who cannot join us directly. He says, very interesting, Jill. Thank you very much.
Thank you.
And with that, Jill, we will have time at the end to address further questions to you. I would like that we are moving on to the next presentation. And now I have to look at my files. Luke Correa is from Tanzania, and he looks at the importance of livestock manure in crop production in Tanzania. Luke, can you hear me?
Yes, I can hear you.
Perfect. I think without too much further delay, please do share your screen with us. Or is it a pre-registered? No, it's a shared screen.
No, I'll share my screen.
Okay, perfect. So another presentation also coming out of collaboration with IITA, I guess.
On this particular one, we were not collaborating with IITA.
This was not, sorry, I got this wrong. Yeah, apologies.
Yes.
So Luke, you share your screen. I see. You know how to do that? Yes.
Yes, let me try. Can you see my screen?
Not yet. Now there was a short indication of your screen.
I can see a screen.
You can?
Can you see it?
Yes, I can.
Okay.
You cannot. Okay, now we are there. Just put it on view mode in the PowerPoint, and then we go. Oh, this was with ILRI. I didn't want to say IITA, I wanted to say ILRI early on.
Yes, it is ILRI.
Okay.
Can you see my screen?
We can see your screen. Just put it on view mode instead of in presentation mode instead of the whole screen. And then we can start.
How can I say view mode?
Perfect. You can go ahead.
Okay. Thank you and welcome all to my presentation. My name is Luke Korir. My colleagues Niels and Henry, I think, are unable to attend. We are looking at the importance of livestock manure in crop production in Tanzania. So it is widely understood that soil nitrogen depletion is an important constraint to crop productivity in sub-Saharan Africa. And the mineral fertilizers are expensive, farmers are unable to apply recommended levels. But on the other hand, we are seeing an increasing role of livestock in livelihoods of poor farmers. As livestock numbers increase and intensification of livestock production increase, more and more manure from livestock is produced. And we think this is a potential solution to soil nitrogen depletion. Although the positive effects of manure on crop productivity is well established, it is also dependent on how the manure is handled before it's applied because of the volatility of the beneficial value of the manure. The aim of our study is to assess how small-scale farmers in Tanzania manage soil fertility and manure, and how their application of manure affects crop productivity, and also to identify which category of farmers are more likely to benefit from the use of manure. This study is based on data from a cross-sectional survey of livestock keeping farmers, which was carried out in 2017. And it covered a whole range of relevant characteristics of smallholder livestock keepers. A total of 994 farmers were interviewed. We analyzed the data using descriptive statistics and econometric analysis. On the econometrics part, we ran an OLS, ordinary least squares regression model, to identify the relevant factors that affect crop productivity. This is a map of the distribution of households which were interviewed. So we can't say it is representative of the country at large, but it's quite a good sample size. Now we go into the results of our analysis. And we have here two bar charts. One on the left is looking at how manure is handled. And on the right is how farmers, what the practices that farmers apply in trying to manage soil fertility. On our left, we can see that there are very low frequencies of farmers handling manure in any particular way. The highest is only 4.4% who try to enclose the manure to prevent it from elements of weather. Otherwise, a majority of the farmers, up to 95%, do nothing at all to protect the manure. And a lot of it is just left open with there are no biogas digesters. Only one or two are found among the interviewed farmers. On the right-hand side, we can see that a majority of farmers actually utilize manure, up to 87%. Mineral fertilizer use is around 22%. So those who use both manure and mineral fertilizer, 22%. And those who use manure alone are around 56%. This is a look at how the fertilizer and manure are applied to which crops. On the left-hand side, we have mineral fertilizer, and we find that it is applied to a narrow range of crops compared to manure. Now we are looking at a description of the variables that we use in our modeling. And here is the table on output. I will highlight what we found to be interesting. So on that, we see that we compare households that applied manure to crops and those that do not. And we find that those that apply manure have significantly smaller herds of livestock and have larger household numbers and larger farms. Those who apply manure still achieve higher value of production. And we find that a high proportion of female-headed households were more likely to apply manure. Those who apply manure also are more likely to also use mineral fertilizer than those who do not. These are the results of our regression model. And I will move to what we find to be interesting. So on this, we find that both fertilizer and manure application have positive effects on crop productivity. However, the effect of mineral fertilizer is greater. We do an interaction term between the use of manure and mineral fertilizer, and we found a negative effect. And what that means is that the effect of manure reduces when you introduce fertilizer and vice versa. The last point here is that high livestock numbers and large farms and the age of household heads have negative associations with crop productivity. So we can make some conclusions from the findings of the study. And one of them is that although most farmers use manure, they hardly effectively use it as recommended. In addition, farmers with more livestock and large farms are less likely to intensify through soil fertilization. We can also conclude that the category of farmers that are more likely to benefit from manure are those who currently do not apply either mineral fertilizer nor manure. And we recommend incorporating in extension the importance of proper manure handling as part of capacity building for farmers. And this is especially where there are problems of soil fertility, so areas with soil erosion, and where farmers do not access fertilizers. We find that this study is based on binary variables. We have binary variables for manure and for fertilizer use. So you find that the interaction terms switch before we know which levels of manure or fertilizer it switches on or off. So we think other studies could use actual quantities of manure and mineral fertilizer. Thank you.
So, Luke, thank you very much. Also, thanks for staying on time. We are ready to receive questions from the floor. I see in the Q&A a couple of questions that I'm going to ask. First of all, what is the price of N and what of the organic fertilizer? That's a question from Lawrence Bachmann.
Please, can you repeat? I didn't get the question.
It's a matter of the costing, the price of mineral as compared to the organic or the farmyard manure. Do you have any indication about the economics of the price levels of at comparable rates of organic or farmyard manure as compared to mineral fertilizers, because you had only 23% of farmers actually using minerals.
Okay. So for this particular study, we didn't have access to data on prices and prices of fertilizer, but from the field observations, the manure is quite cheap, and the market for manure is not that highly developed. But I would think that the price of fertilizer is many times higher. Thank you.
Okay, I have another question here, and that's related to the average application rates of the farmyard manure. Would you like to say something about that?
Unfortunately, again, we don't have access to that data. So what we could observe from this data is whether they used manure or not, and it's quite a limitation of our study here.
Mm-hmm.
Yeah.
There's another question. How would you get more quantities of organic manure or farmyard manure? Because this is, after all, the key constraint. So where would you expect to obtain sufficiently large quantities when we look at Tanzania or at the region?
Okay. So the regions where manure is in abundance is actually in the pastoralist areas where there are large numbers of cattle and less use of it in crop production. Mm-hmm. It's actually burnt as part of the disposal process in most of the households that we went.
Mm-hmm. And there is no way to make arrangements between, let's call it, the semi-nomadic pastoralists and crop farmers to let these pastoralists onto your land and to allow deposition of farmyard manure? Are there any, let's call it, social ecological arrangements in the community?
There is no arrangement of that type because it's only in areas where there is intensive production of organic crops that you would find a market for manure. For example, in the banana growing zone, there is quite a well-developed market. But so far, there are no arrangements with pastoralists on how manure could be collected from them for use in crop production.
That may be an approach for the future to consider. Okay.
Yes.
I have no more questions in the Q&A. And Luke, thank you very much for your presentation. We will move on to Laura. So Laura Kuonen from the University of Bern in Switzerland, and she will talk about rapid early growth outranks wheat competition in horticultural systems in semi-arid Bolivia. At the first glimpse, the title is not talking about organics, but you will see the paper is actually. Laura, would you please share your screen, and you have 10 to 15 minutes for your presentation.
Okay, I can't share my screen as long as Luke is sharing his.
Okay, you have to stop sharing your screen, I'm sorry.
Yes, yes.
Right.
And now Laura is going to jump in.
All right, just 1 second.
I still see Luke's screen. Oh, yeah, no. Mm-hmm.
Okay, I just realized that I'm having a bit of trouble with Zoom. It does work. Sorry, just one second.
I think I already unshared. Is it still showing?
No, you have unshared now. It's okay.
Okay.
Can you now see my screen?
Not yet. Yeah.
Now it should be fine, right?
Look. Yes, we are fine now.
Okay, perfect. All
Okay,
right.
Laura, floor is yours.
Thank you very much. Welcome to my presentation about my field trial about mulch and horticulture systems in Bolivia. My name is Laura Konen, and I conducted this field trial for my master thesis. So, as we have also heard in the previous presentations, low soil fertility is a major constraint in the agricultural production in the tropics, and very often the yields are far below what could be obtained. This is also the case in Cochabamba, Bolivia, where we have a lot of problems with soil degradation, overgrazing, soil erosion, and of course also low soil fertility. In the last 15 to 20 years, these problems have been tackled with the implementation of dynamic agroforestry systems, and many agroforestry plots have been established since. Mulch, as you all know, is one of the options to improve soil fertility among, for example, also as we have heard, biochar, intercropping, rainmeal, chipped wood, etc. And this material from the agroforestry plots can actually be used for mulching. And this material can also be applied to onions, which is a very important crop in Bolivia. After tomatoes, it's on the second place of the most consumed vegetables. So what did I want to find out with this field trial? My aim was to assess the potential of organic mulching material from these agroforestry plots on onion and wheat parameters, and to compare those to the mineral fertilizer application. So this trial was conducted at Moyes Nechta, which is the Center for Andean Agroforestry in Cochabamba, Bolivia. And as you can see here at the cross, this is where Cochabamba lies more or less. It's between the highlands and the lowlands. So it lies in the inter-Andean valleys at an altitude of around 2,500 meters, and it's a semi-arid region. This trial was set up as a randomized complete block design with 4 blocks and 7 treatments, and it was conducted between January and May last year. So as you can see here on this picture, on this side you have rather low trees, and here we have rather high trees. And this was the factor which we used to block the trial. In total, we had 7 treatments, of which we had 3 mulching treatments, which you can see down here. The first one, which is the Dodonea viscosa, is leguminous shrubs. And then we have the Homocysthisus proliferus, which is a non-leguminous shrub. These shrubs are both grown in the agroforestry plots. And then we have the grass Melinis repens, which is very common in this region. As you can see, these mulching treatments applied around 40 kilograms of nitrogen per hectare, but the Melinis repens itself had quite a lower amount. We also applied urea treatments of, we had one with 80 and then the other one with 40 kilograms. We looked at the onion growth parameters when we assessed them every 2 weeks. We looked, for example, at the length of the longest leaf or the number of green leaves. Afterwards, we also considered the wheat biomass, which was assessed at 8 weeks after planting. And finally, the harvest took place at 19 weeks after planting, and we looked at the below and above ground biomass, as well as the number of harvested plants. The analysis, the statistical analysis, was conducted in RStudio, and we used mixed effects models. Now, let's look at the growth parameters. We found that the growth of the mineral fertilizer onions was much faster and earlier than the growth of the mulched onions. And here you can see that the green treatments are the mulch treatments, and the urea is then the red ones. And what is also important to note here is that we did not find any difference between the 3 mulching treatments. As for the wheat biomass, we did not find any difference between the mulching treatments either. And also there was no difference between the mulch treatments, which applied around 40 kilograms of nitrogen per hectare, and this mineral fertilizer, which applied the exact same amount of nitrogen. But what is important is here that the treatment with 80 kilograms of nitrogen per hectare, it showed quite a very high wheat biomass, and this was significantly higher than all other treatments. Here I'm showing you one of the harvest parameters. So the below ground onion biomass, which is basically the onion bulb yield. And here we have actually the same or a very similar picture as we've seen with the wheat biomass, where we have the urea 80 treatment with a very high below ground biomass and also a high harvest index. And this was also significantly higher than all 3 mulching treatments. Here we also see that the Melinis repens, so the grass treatment, was the one which performed best. If we now look at the total onion biomass, so the above and the below ground biomass added, we see that there are some differences showing here. The urea 80 was still the highest, which is still the treatment with the highest total biomass. And it was significantly higher than all treatments except the Melinis repens. The early and rapid growth of the mineral fertilizer onions was due to the immediate nitrogen availability of this fertilizer, whereas the mulch itself released the nutrients only around 10 weeks after planting. As the onions, also the wheat profited from the early nitrogen availability. And it seems that the soil covering effect of the mulch did not influence the wheat growth. And what also needs to be noted here is that we probably had quite a low wheat pressure overall. So in the yield parameters, we did find some differences between the mulch treatments. The grass mulch itself, which added the lowest amount of nitrogen with 26 kilograms per hectare, showed the highest above ground biomass, the highest onion bulb weight, and also the highest total biomass of all mulching treatments. And here we believe that the soil covering effect of this grass led to a higher water availability and also to these higher parameters. We also found that the mulch itself did not perform better than the equivalent urea treatments, because the mulch led to a later development of the leaves, and this meant that the energy was rather put into producing leaves and not yet into producing bulbs. And what is important to note here, and what is kind of a surprise, is that the Melinis repens, so the grass mulch, showed the same onion bulb yield as the equivalent mineral fertilizer. So my aim was to compare the mulching treatments to the urea treatments and the assessed effect on onions. And we see that clearly the higher and easily available input led to a faster early growth and also a higher yield, regardless of the wheat biomass we found on the plot. And of the mulches, the grass Melinis repens was the best performing mulch, even though we had the lowest input of nitrogen. So now the question is, what does this mean for the practice? What does this mean for a farmer who wants to have a high onion bulb yield? So my recommendation depends on whether mineral fertilizer is available and affordable. If the answer is no, then I would definitely say Melinis repens is an option to increase the onion yield. And if it is available, then mineral fertilizer is definitely a better option to have a higher onion yield. But I think also another option which was mentioned today is that it would be to combine both. But of course, this was not assessed in my trial, but I think it would be important to assess it in further research. So thank you for your attention, and I'm now looking forward to your questions.
Thank you, Laura. Interesting presentation. I'm just wondering, I have been working myself with Dodonea viscosa in Eastern Africa, and it's a pioneer plant of rocky outcrops. So how is the availability? Why did you use this plant in crop fields when it's actually growing in wastelands on rocky outcrops? Or is the availability so high of this plant?
I actually chose these mulching treatments. Well, the first one, the Dodonea and the Homocitus, I chose those because they are grown in these agroforestry plots. They're used as accompanying plants. So they're grown to produce biomass, which is then cut once or twice per year. And then this material is used for the mulching. This is the reason I used those two materials.
Were you surprised that you didn't get a stronger weed suppressive effect? Because Dodonea is known to be strong allelochemical effects and can suppress weeds substantially. What would you say? How would you comment on that one?
Well, I would say that maybe I can show you the graph with the weed in itself. You also see that there's no difference to the control. Which when the control, we did not apply any mulch, we did not apply, so we didn't have any soil cover, we didn't have any nitrogen addition, and we didn't find any difference between control and the mulch treatment. So I would say that the weed pressure was relatively low.
Okay.
And also that the weed growth, which is shown here in the nitrogen mineral fertilizer treatment with 80 kilograms, was due to the fact that the wheat grew because they had nitrogen. Yeah, so this was kind of, this would be my explanation.
Okay, I have a question from the Q&A here. Why include fresh farmyard manure? Normally, fresh farmyard manure is not recommended for onions. It should be compost, or we should use older materials. Would you like to comment on that?
Yes, we used compost. Well, it was not fresh farmyard manure. It was actually, we didn't really have much information on this farmyard manure. We just knew that it came from the Altiplano, so from the highland of Bolivia, where they have a lot of cattle, and it was left on the field for maybe a year. It was covered with a plastic sheet. This is all the information we have. So it was actually not fresh farmyard manure.
Okay, Laura, thank you very much. We have to move on to the next presentation. Thanks for your contribution. And we are now, apologies. We are now moving to Raul Lopez. Raul is currently in Cuba, but he's listening in on us and he has sent a presentation. And we are going to view the presentation he had sent beforehand. So we will have his contribution and I will read on his comments then later on, try to answer your question you may have to him directly. So Laura, will you please stop sharing your screen? And I would ask our technical assistants from ATSAF to upload the pre-registered presentation from Raul Lopez on nutrient cycling with sugarcane ash in urban agriculture, and here showing results from lettuce and cucumber.
Good morning. My name is Raul Lopez. I'm from the Gran University in Cuba. Thank you for the opportunity to present my research in Tropentag. The title of my work is Nutrient Recycling with Sugarcane Ash in Urban Agriculture, result for lettuce and cucumber. In Cuba, the sugarcane ash is produced in enormous quantity and as a residue of the island and constitute a environment risk. Cuba has several agroforestry factories and produce several ton per year. This is a risk, the residue of the sugarcane ash for the environment. Currently, the lack of research prevents the adequate use of the sugarcane ash for maintenance for soils. The utilization of sugarcane ash in agriculture is an important issue to create nutrient cycles and safe fertilizer in Cuba. In our country, it's very important the urban agriculture The name in Spanish is organopónicos, and they produce based in the compost substrates. However, the use of the biomass ash in sugarcane garden is rarely investigated until now. For the current situation, the problem of this research is the low fertility of the substrates used in urban agriculture directly affect the yield of horticultural crops. Therefore, every year thousands of tons of sugarcane ash not reused, which become another environmental problem. The objective of this work is increase the yield of horticultural crops, cucumber, in this case cucumber and lettuce, and increase the substrate fertility and by application of the sugarcane ash. We carry out two experiments, one experiment in controlled condition and use for treatment. We apply 2 doses of the sugarcane ash, one control for NPK fertilizer and one control without application. We use plot with 1 kilogram of soils. In the field condition, this is a picture of the field condition, we apply 8.5 tons per hectare of ash and one control. The results in control condition, where we show the table, we obtain good yield of good behavior of the different treatment, row length, shock length, dry matter, raw dry matter, and leaf area. We apply the 14.4 grain ash per plot. For example, the best treatment for we will apply the chemical fertilizer, but it's possible to obtain good level of the parameters when we apply the sugarcane ash in cucumber. Then in lettuce, we obtain the same results. The treatment, the control of the chemical fertilizer, or the best behavior in the different parameters, but it's possible to obtain good values of the shock height, row length, dry matter, and raw dry matter, and leaf area when we apply 14.4 grain ash per plot. And the experiment in field condition, this is a picture, an aerial picture of the experiment lettuce and cucumber in the aeroponic in my city. And we obtained that when apply ash fertilizer, we obtained the significant difference when in the length of fruit and the diameter of fruit and the yield of the cucumber. This is a picture of the cucumber in the field condition. In lettuce, we have the same behavior. The best value of the dry matter, and the other indicator was when I applied the ash fertilizer. The sugarcane ash have a good effect in the macronutrients in lettuce plants. We obtain was better. They increase the value of the phosphorus, potassium, sodium, calcium, and magnesium. And the application of sugarcane ash in the chemical characteristics of soils, in this case the substrate, after the application of the sugarcane, the value of the phosphorus, potassium, sodium, the phosphorus, potassium, calcium, and magnesium increase after application of sugarcane ash. The conclusion of our research was that despite the higher yield and following higher nutrient removal, increased the level of phosphorus and potassium were still found in the soil after plant harvest. Also, the garden base of nutrient-rich compost substrates, the result has shown that adding biomass ash can further increase the vegetal yield here. And the ash also can replace mineral fertilizer apart from nitrogen, which is not present in the ash. Thank you for your attention.
So, thank you so much, Raul, for this presentation on sugarcane ash. I go back to the question and answer session so I can see what you are contributing. Now, when I look at your data, the sugarcane ash appears to be primarily a potassium source. It only affects the potassium content of the veggies, and it increases mainly the potassium content of the soil. Is this correct, this assessment? Now I cannot, I don't have Raoul online. I have to see here. Raoul, do you think it's possible that you can reply to the questions by writing something? No, it's not possible. He can hear us, but he cannot correspond with us. So let's just stop it there. We thank Raoul for his contribution, and you have to stick, or maybe you ask your questions later in the general session, and I'll pass them on to Raoul. And then we are moving to Elijah Gogo. Elijah is looking at integrated use of NPK fertilizers, of cattle manure, and on the role of frequency of leaf harvesting for nutritional quality of butternut. I would wish Elijah to please move online. And do we have a shared presentation, or do we play a pre-registered presentation? I have to ask this question now to our technical assistants. Okay, we have a pre-registered presentation. I also see that Raoul is here and he listens in to us, but we will ask the questions maybe a bit later, and I will read them out to Raoul or type them to him. So right now, Elijah, you want a pre-registered play of the presentation, so.
Hello and welcome to my presentation on integrated use of NPK fertilizer, cattle manure, and frequency of leaf harvest for improving nutritional quality of butternut. My name is Elisha Gogo. I'm a lecturer at Pond University. I'll take you through the background information all the way to the conclusion of the finding. Butternut is a common fruit, a common vegetable in Kenya, which is mainly grown by small-scale farmers, where its fruit and leaves are consumed as a vegetable. The issue is that the timing of leaf removal normally has the effect on the ability of the plant to recover after leaf harvesting. And this has a very big influence on the leaf and fruit yield and quality. It's also important to know that soil nutrition, or the level of nutrients in the soil, play a big role on the ability of the plants to maintain sufficient leaf cover, especially after defoliation or leaf harvesting. This is important because when you harvest the leaves, or you harvest the crop, normally you take away nutrients from the plant, and therefore if you don't replenish this into the soil, there will be depletion of nutrients, and therefore this will affect the crop growing. There's limited knowledge on the frequency of leaf harvest and soil nutrition, which has a very big influence on the quality of butternut. This is more so in Kenya, and I want to believe also in most of the African countries. Therefore, the objective of the study was to determine the effects of NPK fertilizer, cattle manure, and leaf harvest frequency on nutritional quality of butternut. So this is the fruit of the butternut, and these are the leaves of butternut, which are mostly harvested during the vegetative growth, and therefore there should be a very important balance between the two, because if you harvest most of the leaves, then this has an influence on the food, because as well as the leaves themselves, because of the photosynthetic surface tissue and the relationship between the sink and source of plants. This study was done in Kenya, and the variety that was used was Waltham, or sometimes they call it Waltham, a very common butternut variety. And the experiment was randomized. It was used in a randomized complete block design with 3 applications. The treatments were synthetic fertilizer at 0, 250, 500, or 750 kilograms per hectare, cattle manure at 0, 2.5, 5, or 7.5 tons per hectare, and leaf harvest frequency was done at 2, 4, 6, or 8 weeks interval. This was done in all possible combinations, and leaf harvesting started 8 weeks after planting, where 6 leaves were being harvested per plant. The land was plowed and then harrowed before planting, and NPK fertilizer was applied in 2 equal splits, one at planting and another one 4 weeks later. Cattle manure was done once, was applied once during planting, where it was done by mixing the manure thoroughly together with the soil. 2 seeds were planted per hill, then 2 weeks later one was thinned to allow only one to grow. Rainfall was the main source of water, but in cases where rainfall was limited, manual irrigation using watering can was used to supplement. Data was collected on soil and cattle manure, the nutrient composition. Then leaves and fruit of butternut was analyzed for total carotenoids, vitamin C, protein, carbohydrates, and dietary fiber. This is the results for soil and cattle manure analysis, and you can see that the cattle manure has sufficient had enough nutrients to support plant growth. And looking at the results of the total carotenoids, you can see that combining cattle manure and even at lower rates had a better influence on total carotenoids compared to when they were applied alone. And this was the case even for the fruit, you can see here. Okay. Moving on to vitamin C, there was a little difference, particularly with the soil application and the combined use of NPK and cattle manure, but still this was still much better where compared to when no NPK or cattle manure was applied, and the case was still observed in the fruit of butternut. Looking at the protein content, the influence between the soil application and combined application was not so much big, especially for the leaves, but look at the fruit. Combined application of NPK and cattle manure, even at lower rates, had a higher influence on protein content compared to the soil application or no application. Also, carbohydrates was greatly influenced by cattle manure or NPK fertilizer, and very interesting was even at the soil application where cattle manure was used. You could see that when you apply when 2 leaves are harvested, when leaves are harvested on 2 weekly basis, the carbohydrates content was so much increased compared to harvesting leaves less frequently. Looking at the fruit content on butternut fruit, you could see that the combined application of cattle manure and butternut had a very great influence on carbohydrates content compared to sole application or no application. The same was also observed for dietary fiber, where combined application of cattle manure or NPK fertilizer had a very big influence on dietary fiber on both leaves and fruit of butternut, even at more frequent leaf harvesting. So, in a nutshell, the study shows that combining 250 kilograms per hectare of NPK fertilizer with 2.5 tons per hectare of cattle manure was sufficient to improve the nutritional quality of butternut, even at more frequent leaf harvesting. That is particularly 2 week leaf harvesting frequency. The effect was mainly attributed to the improved soil physical, chemical, and biological characteristics. Therefore, integrated use of NPK fertilizer and cattle manure may help to improve the nutritional quality of butternut even when harvesting leaves more frequently for consumption during the vegetative growth of the butternut. So with that, I would like to say thank you very much, and I welcome any comments or questions concerning my presentation. Thank you.
Asante sana, Elisha. I cannot hear anything anymore right now. There seems to be a technical problem. Maybe just for those who are not aware, a butternut, that's Cucurbita moschata, the Moschuskürbis, as we say in German. Elisha, you have been talking about leaf harvest and leaf eating. Right now, there seems to be a technical problem. Switch off the sound here. Can you hear me? Because I don't have any sound right now for one reason or another.
I can hear you clearly.
You can hear me clearly. Okay, perfect.
I can hear you.
Good. Elisha, leaves are eaten of the butternut. The fruits are also eaten of butternut, I suppose. What is more prized, the leaves or the fruits?
Yes, thank you very much. I hope you can hear me.
Yeah.
Thank you. I think both are important because normally butternut grow in arid and sub-arid areas, and these areas most of the time the people who are living there are sort of poor, and they cannot afford to buy a lot of food. So normally they rely on butternut leaves during the vegetative growth, and then in the later stages of butternut growth, they can rely on the food. So I would say both are important.
Mm-hmm. But the more frequently you remove the leaves, I guess the lower is the yield of your fruits. So there's a trade-off there.
Precisely, and that is a problem that I was trying to look into and see if possible I can solve, because sometimes they overharvest the leaves, and therefore this has an impact on the fruit yield and quality.
Mm-hmm. And applying 750 or 7 tons of farmyard manure or 750 kg of NPK, is this something realistic for butternut producers? It seems like huge amounts that you're applying there.
Yes, you're right. Normally,
For NPK, the recommended one, which is sort of one for most of the cucumber beets, is 500 and I think 500 kilograms per hectare. But for the manure, it's in tons, which is 7.5 tons per hectare. So I was trying to see if we can be able to reduce the application of cattle manure as well as application of NPK fertilizer. And therefore, we found that we use 250 kilograms per hectare of NPK fertilizer and 2.5 tons per hectare of cattle manure was still able to help farmers to get better food yield, even at a more frequent leaf harvesting.
Mm-hmm. Okay, thank you. I'm looking at Q&A and I see no questions there. Anybody of my colleagues here in the room, in the chat of Zoom, is wanting to ask a question to Alicia? Because if not, we can open the floor to any kind of question now that you may still have to any of our presenters. Are there any points to be made? I think what we have seen is a range of different approaches to organic matter amendments. One of the points I think in our control studies that we have to critically review in future is the very large amounts that in some studies that are applied. Will we reach these beneficial effects that you have reported when we are moving down to, let's call it, realistic quantities of applied organic amendments? And that's still an open question because many studies are just, I think, using extremely high rates. They show the obvious positive effects that you have reported on today, but is this something that is really an option for the future? It's an open question right now. Does anybody want to comment or ask questions to any of our presenters? Then please do it now. We have still 2 minutes left. I'm still waiting for Q&A. There's nothing new. Ladies and gentlemen, there is something more general. This is a question from Q&A. Something more general. When looking at the impact on the nutritional status in butternut, so it's a question addressed to Alicia, shouldn't qualitative yield parameters always be included in general in studies on organic amendments versus combined or sole mineral fertilizer applications? So once more the question, the nutritional status, the effect of organic amendments, these nutritional quality aspects, shouldn't they always be a component when we compare mineral and organic fertilizer sources instead of only looking at yield or biomass or something like that? So it's a question, I think, to all of our speakers here. Who wants to reply?
Maybe I can say something. Okay. I didn't get the question so well, but I want to assume that is asking about the issue of when they're looking at the yield component. Is it also important to include the nutritional aspects of the plant you're studying? They want to believe that both are very important because in some cases you can find that the yield has increased, the quantity aspect has increased, but the quality aspect is either not affected or is reduced. So it's important that when you're looking at the fertilizer or manure used in crops, it's good to look at both the yield and nutritional aspect. And also the cost implication is very important because these fertilizers are very expensive, especially the synthetic ones. So cost implication also has a very big bearing on the study that you're looking into. Thank you.
Okay, I think we can take this as a closing comment to the session. I wish to thank all our speakers. I want to thank those who have contributed with their questions and you out there watching the session on YouTube. I wish you a very enjoyable remaining Tropentag and have a nice day. Goodbye.
Thank you. Goodbye.
Bye, thank you.
Bye, thank you.